Okay, so brief intro of who I am. I am the CTO of DefenseStorm. We are a cloud cybersecurity company. It's a SIM in the cloud, so you send all your events to us. You can alert and search and do all that kind of stuff on them. Gave a cool talk last year at ShmooCon called LostPass. It was kind of a cool phishing attack against LastPass. It got all of your credentials, including your two-factor. Stole all of your data. It was a really cool phishing attack. And then last year at GBC05 I did how to implement crypto poorly. I basically found maybe 20 or so examples of completely hand-rolled crypto, like not even using AES or MD5, like making up their own stuff, finding where companies were actually using it, and then kind of my adventure in trying to get them to not do that, which was not super successful. But here I'm talking about software as a service today. So software as a service, basically everybody uses software as a service nowadays. It's basically becoming the predominant model of software delivery. All of these companies, HubSpot, Snapchat, Gmail, Google, all of these are different examples of software as a service. You don't buy software anymore, you buy the software service. You don't run the computers anymore, you buy the whole thing. It's a huge market. It's over $100 billion a year in revenue now, and it's projected to keep growing. So this is an absolutely enormous market from a value perspective, and security people need to know, what to do to test it. Some motivation from Dina Dezovi. I really like this tweet. In 10 years, there'll be 3 major operating systems: Amazon Web Services, Google Compute, and Azure. And it's kind of a very different way of thinking about computing, right? We're no longer thinking, Windows, Mac, Linux. We're thinking, how do I do this on AWS? Maybe, Lambdas or Google's BigQuery. Another bit of motivation is there was a executive order, I think last week, basically mandating the federal government to move to the cloud, like cloud.gov. So even the federal government is moving to the cloud and to kind of SaaS software development with 18F and that kind of stuff. So my goal for this talk is to explain how SaaS software is made and why that's useful for security people to know, and vice versa if you're a software person, why, like what you're going to be doing wrong. This is kind of a really huge, broad topic, so this is an introduction. This isn't going to be a deep dive in any particular area because I'm going specifically for breadth over depth. Okay, I like to start my talks with a conclusion. So my conclusion is that access to a developer's laptop is basically equal to access to everything. If you can get access to them, you're in. If you have access to the build server, you also have access to everything because now you can backdoor everything it builds, that kind of stuff. If you have access to the artifact server, well, now you can upload backdoored artifacts and still get, access to everything. If you have access to the configuration management server, you have access to everything because you can control how nodes are provisioned. If you have access to the NoSQL database, you basically have access to everything because now you have all of the data. Or the Docker container configuration or the cloud API. Really, access to anything is access to everything. This is a really kind of unfortunate state of affairs. So why are SaaS companies different? Why is it not just exactly the same as every other company? So SaaS companies have a fast, iterative development process. They usually take, hours to days to deploy new software instead of weeks, months, or quarters, or years. Lots and lots of automation. Developers like to pride themselves in I didn't have to click many buttons to get this out. It was all automatically tested and deployed. Automatic monitors let me know when it stops working. Engineers are very, very empowered. Usually they have access to production. They like to do lots of stuff. They provision new nodes, they do lots of crazy things, and they have very powerful tools to do so. And these new powerful tools, while they're great, they can be used by attackers to great purposes. And this isn't really specific to SaaS companies, but there's, just like everywhere else, there's really a lack of security culture. A lot of engineers don't know what exactly they need to do to secure their software. Sometimes they'll go to DEF CON and then kind of take the wrong impressions away. I've seen that a lot. And they don't really understand the kind of risk-benefit trade-off. So all of those differences also correspond to weaknesses. So the fast iterative development process really, you need linchpin servers, right? So you need your Git server and your Jenkins server and your Chef server. You need all these specific servers that are very, very crucial to your SaaS deployments. Even though there's lots of automation, there's not usually a lot of security monitoring. Really advanced startups and SaaS companies will have good security monitoring, but that's definitely not the norm. Really, there's no security strategy or planning. Those powerful tools can be used for evil, and there's really little to no budget for security. Maybe they'll get, Graylog or Elasticsearch monitoring their logs, and that's it. So how do SaaS companies work? So step one, the engineer needs to write the code. They're going to take the product spec, and they're going to write the code. They're going to make it do what they want to do. Engineer is going to commit the code, usually to Git Subversion. They're going to push it somewhere. And then continuous integration, Jenkins, Travis, Circle CI, something's going to build the code and run the tests. Even if you're using Python or something, it doesn't technically have to be built. It's probably going to be packaged, something is going to run the tests. Then it's going to be automatically deployed to dev, which is usually the name of your development environment. Sometimes there's other different names. So Jenkins is going to deploy it to dev, and then you might have a staging or QA environment. Sometimes that's automatic based on tests, and then deploying to production is usually manual, although some really advanced companies like Facebook or something have that completely automated. As long as it passes all of the tests, it goes out. But how does just this part work? Let's dive in just here for a second. So this is Jenkins. I'm sure a lot of you have seen Jenkins before. You can start up new projects on here, get them building, get them tested very easily. It supports basically every programming language. And it's most used by Java because that's kind of its bread and butter, but you can do anything with Jenkins. So how does Jenkins work? The build is triggered. Either it's polling or a webhook, something like that. The source code is downloaded. The source code is compiled. Tests are run. Software is packaged, and then it's uploaded to the artifact server. So now let's go through some of these steps. So here is an example of how to kind of break in. If you're kind of thinking of a SaaS company as a separate sort of entity, we want to run our code on Jenkins, right? Because I said it was a linchpin server, and if we run our code into Jenkins, we can backdoor everything that it builds. If we backdoor everything that it builds, we have access to basically, dev, staging, production. We win as attackers. One thing I noticed is that basically anyone can submit a pull request on public GitHub projects. Some people use Jenkins for their public GitHub projects. So I was wondering, if we submit a pull request, will it just run our code, right? If I just submit a test, will it run our code? And actually I found this tweet. Yes, it will. So actually there are people out there that make pull requests that literally just replace all the tests with Bitcoin mining code, and now they have Jenkins or whatever running Bitcoin mining code trying to get, Bitcoins mined. And this works. Apparently this works. This works on several different continuous integration servers, and it's usually where it's set up to automatically build and run tests. The most popular GitHub pull request builder, though, has one caveat in here. When a new pull request is opened, it will actually post a comment in there saying, can one of the admins verify this patch, right? Which seems reasonable, so that the admin can check and make sure that all the code hasn't been replaced by some kind of Bitcoin mining code, right? So I was sad about this because this is, as an attacker, now I can't add my Bitcoin mining code or take over the Jenkins, right? So I tried it out. This is my pull request. And I noticed that after the difference between my pull request where I wrote ABC and where the bot replied, can one of the admins verify this patch? I noticed it was 5 minutes. 5 minutes seemed really suspicious to me. It seemed like polling. And that's exactly how it works. So this is how it works. Every 5 minutes, it's going to poll all open pull requests. It's going to find every open one, check to see if either the author is whitelisted, like, I trust James or whatever, to write not Bitcoin mining code, or if the pull request is accepted, the admin said, yes, you should run the test because I am going to merge this. If not, post a comment, and if so, build the pull request and run the test. So we want to get to step 5, right? Step 5 is where we want to get to because we want to run our tests. But we don't want to have the admin looking at our malicious code. So how do we do this? We're going to post an innocuous pull request that requires running the test. Maybe we refactor the code, something, right? It requires running the tests. The bot will post, can the admin verify? Presumably the admin will say, test this please, right? Because everything's good. But then within 5 minutes, I have 5 whole minutes now, I can force push a new malicious commit. This is how you force push. You just git commit amend, you overwrite your old one, you force push it. And this is important because if you don't do this, if you just add a new commit, GitHub's going to send a message out to people saying, hey, a new commit was added, and you want to avoid this email because you're trying to trick the admins. And then if you do this, like I just did, so I'm the admin, right, test this please, and Jenkins ran my test here. But what did it run? So this is the thing I force pushed. I actually added, just the string. I'm going to print out the string hacked, but obviously you could put some more malicious code in there. And on my Jenkins, we can see it's building my pull request right here, and it actually ran my hacked version. And the admin had approved the one without this. So because of this, the admin had basically allowed the running of malicious code. And if you look around, this is a very popular pull request plugin. Lots of people use it, and it has this kind of inherent race condition built in. So what do you do if you do get shell on Jenkins? There's a few different ways you might get shell on Jenkins. What do you do? So the best thing about this is you can read or write any file Jenkins controls. It has no segmentation. It has no chroot or anything like that. It basically, if you get access to Jenkins, you can read and write as a Jenkins user. So what can you do? The config.xml file is a file that controls the configuration of Jenkins. You can add your own plugins. You can do that kind of stuff. The credentials.xml, that's a really fun file. That's where all of the secret OAuth tokens for GitHub or username and passwords for Artifactory or something like that will live. You might even have SSH username and password in there. .m2, that's if you're a Java developer, that's where all of your libraries are. So you can actually backdoor libraries so that when the code is built using .m2, all of that stuff is going to be taken in there. Secrets is where you get basically the keys to decrypt the credentials file. And the workspace down there, that's actually where all of the code lives. If you want to actually backdoor the code itself, it's all there. So if you want to backdoor jars, this is the way I do it. So the victim.myClass, this is going to be the main class for whatever the victim is. This works with Spring Boot or anything in Java. And you don't actually need the actual class. You can just basically make a dummy class that has that exact signature, and all you need is this class file after you compile it. Obviously, you're not going to print out hacked. You're going to do something more interesting. You're going to have an interpreter reverse shell or something cool in there. And it's very easy to add to the jar file. So all you need to do is tell Java that you have a new main class. My path is called hack.hacked. And what you need to do is you first need to add the your class to the victim.jar. That's what the first jar line does. And then you need to add your manifest file to victim.jar. And then once you do that, your main file is going to run before theirs, and then you're going to call theirs, and then that is backdoored. Very, very simple, very straightforward way. This isn't super advanced. But it's very effective. It's very easy to do by backdooring Jenkins. It's very easy to set up Maven or something to automatically do this for you. And if you want to decrypt any Jenkins secrets, pretty straightforward to do. You just log into Jenkins/script, and it has a script console. And all you need to do is print line hudson.util.secret.decrypt, pop in the secret right here, and it will spit out the plain text of whatever it is. You just take that credentials.xml file, and you can just put in various secrets in there, and it will just print them out. You get OAuth tokens this way. You get SSH keys, Artifactory, username, password, all that stuff in there. There's loads more you can do with this. One talk I really liked was Jonathan Claudius's talk, Attacking Cloud Services with Source Code. Has lots of neat ideas in there about other things you can do. His is more focused on Ruby, but it's basically applicable to any language. So what happens to the build after it's built? It's uploaded to an artifact server. And what's an artifact server? It's basically just a fancy web server that holds versions of software artifacts, version 1, version 2, version 3. Usually you can't delete them or overwrite them, which makes sense, unless it's a development version, which is going to be continuously updated. Your continuous integration is going to keep uploading to this, and your deployment software, whatever that is going to download from the artifact server. Some examples of this is Sonatype Nexus, JFrog's Artifactory, or even a Docker registry counts as an artifact server. And all of these, the Nexus and Artifactory are kind of Java-based, but they support basically any programming language. So if you can upload to the artifact server, maybe you've stolen the credentials out of the credentials.xml, you can upload backdoor versions of code directly. You don't have to do the whole Maven automatic backdooring. You can just use curl to upload to them. Very simple. Just upload file, specify the path, and you have a release there. This is easiest to do on development versions, not tagged versions, because tagged versions you usually can't overwrite. So development versions you can. Deployment. So after we've committed the code, built the code, we need to get the code on machines that are going to be running usually in the cloud. How do we do this? There's two main ways people do this nowadays. Some kind of Linux container like Docker or CoreOS. This is a virtualized OS, and which most people know now is not the same thing as like VirtualBox and VMware. It's a different type of virtualization. Usually all of the dependencies are included. So if you have like libc libraries you need, or a specific Java version or specific Python libraries, all that will be built into your Docker image. And usually your Jenkins will build the entire image. And this is really nice because your developers can put it on their laptops and run the exact same thing that they're running in production without any problems. The other way I've seen people do it is configuration management software, Chef or Puppet, Ansible, Salt, any of these things. They're actually very, very effective at deploying software to nodes in production. And the other thing people use is custom scripts, bash scripts, downloading things from Artifactory, putting them in particular places. So let's talk about all of these. So containers. I tried to find a list of all of the different containers and technologies, and most of these I didn't know about. Docker, Kubernetes, CoreOS, Mesos, RKT, Panamax, Day, Portainer, Rancher, Shipyard. There was about 20 more I didn't have on here. It's crazy. It really makes me want to kill myself. And I like containers and all of this stuff. I think they're really cool, and there's just so much stuff out there. It's just happening so fast. It's really hard to keep up with. And that's if you're somebody who's kind of into this. If you're kind of new to this, there's actually a really funny blog post called The Illustrated Children's Guide to Kubernetes. It's kind of fun. It's a really good, like, little lightweight introduction to this. I like pointing people to this because I get a kick out of imagining kids reading something about this. So containers. So there's security trade-offs. One thing about containers is it's really easy to patch and update. It fits microservices really well, which we'll talk about in a bit. It's easy to automate building and deployment of them. There's actually really, really great tools for building Docker images nowadays and keeping them up to date, building your things into them and deploying. One surprising thing, and that especially a lot of developers don't know this, is that they're not a security barrier. I've actually only met one developer at a developer conference, like not at a security conference, because developers that go to security conferences usually know a little bit more about security. I've only met one at a developer conference that actually knew that Docker was not a security barrier. So it's really not well known, even though that's a pretty standard thing that Docker says. We'll talk about that more in a little bit. And the biggest danger is that all of these tools is that they're pretty new, so even as a security person, you might not be aware of the security trade-offs you're making. So let's talk about those things. So here's an example. So Kubernetes automates deployments of containers. So you might have an SSH Bastion host, right, because you want all of your SSH to go into one machine so you can check it and do two-factor and log and do all the great stuff you want to do because you're a security person. And you might not realize that Kubernetes actually can bypass SSH directly. And this is a cool feature it has. You just do kubectl exec, you specify the pod name or the container name, and you do /bin bash. Now you have a bash cell. And this actually tunnels over 443 to the Kubernetes master. And if you've done all of this work to set up SSH and set up your logging and two-factor and all this stuff so carefully, you just didn't realize that by running Kubernetes now there's kind of a side door into your architecture. And this isn't a bug, this is absolutely a feature, and it's super convenient. And developers love it, but you have to be, careful with this. I got this from a really cool talk at Sector, Crash Course in Kubernetes and Security by Matt Johansson. Really interesting if you're interested in Kubernetes. Another thing, easy Docker root shell. This isn't like super advanced, but this is something that some people don't know about. If the user is in the Docker group, they can basically run containers without sudo, and they have access to root, essentially, because of how Docker works. So this first command is going to start a Docker container, like an Ubuntu image, and it's going to map the user's home directory to /hdocs. And it's going to copy a bash shell in the Docker container to /hdocs, which is the same thing as the user's home directory, called /root shell. And then it's going to set UID that root shell. Okay? So then outside of the Docker image on the host, it's going to, we're looking at the root shell, and it's owned by root on the host, and it's set UID. So even though, in the Docker image you were root, and outside the Docker image you were also root. So when you run that root shell, using -p to honor set UID, you can get a root shell. And this is not a bug. This is absolutely a feature of Docker, and they will not fix this. And this trips people up all the time because they're like, oh, I have Docker. It's like chroot or something. I'll run all my applications as root. This happens. So Docker is really cool for security in some aspects, and it has some kind of pitfalls in other ones. Other things I found was I just decided to look on Shodan for just what I could find for Docker. I found a Portainer on the internet. If you put this kind of stuff on the internet, you have owned yourself, because all of these you can just log into directly from your Portainer here. I can stop anything I want. This is obviously a huge problem. And part of the problem with this is that they don't come built in with authentication. It's all network auth. And that's a very, very common thing with all these new tools. It's like, oh, lock it down, but then people are like, but I want to access it from home or my VPN, and they mess it up and they accidentally put it on the internet. I found another one. This is Kubernetes, and I actually found the Jenkins password just right away. And they were obviously running Jenkins in a Docker, and I could log into it directly, which I didn't do because that would be illegal. But you could do. It was all on the internet, and actually all of their Docker images were also on the internet, which was that was weird. Usually that doesn't happen, but. So you might also see this where people accidentally put this kind of stuff directly on the internet. Okay, so config management is the other major way to deploy software and maybe configure your Docker hosts. So your software might depend on NTPD running and the time being correct, maybe a recent Linux kernel version, ImageMagick installed, hopefully not. Maybe you want to ask the question, are all of your nodes up to date? Like, are they all the current patches? Do they all have these specific packages installed? Configuration management answers all of these questions. One thing that I really like about it is it also gives you a way to peer review changes to your infrastructure, because all of your configuration management can be described in files, which can be checked into Git, and then somebody can review your changes, which is really nice. So Chef is a very popular one. It's not the only one. It's just the one I know best. But basically all of these apply to all the concepts apply to any major configuration management. Chef is cool because it treats infrastructure as code, and you describe what, not how. So like basically every programming language describes how to do something, but Chef does it kind of the other way. It says, okay, well, this directory should exist at opt/application config. That's going to be my config directory. It's owned by a service, and it has this mode. Make sure you create it and create any directories, recursively. And what's nice about this is it's idempotent, so if you keep doing it over and over and over, it doesn't make new directories, doesn't even try to, it just checks that the directory exists. Directory is like the most simple example, but you can make very, very complicated resources. Like this is my entire application, and then you can describe in Ruby code exactly how that works. Knife is the command line tool to interact with Chef. Chef is very kind of cutesy. It has cookbooks and recipes and knives. It's kind of annoying, actually. In .chef knife RB, this tells you where the Chef server is. If you get access to your developer's machine, this is going to tell you where their Chef server is. And this is their key to talk to the Chef server. You need both of these. You just put them in that directory. Knife will use them, and now you can talk to their Chef server. So you have access to their Chef server, and now you want a list of every node in every environment. This can be very useful for you. You just do knife node list. It'll print out every single node with helpful names and descriptions. You want to see installed packages for every machine. You just search. The quoted asterisk is basically just all. You can specify environments, or you can segment that up a little bit. And the -a packages tells it, I want to see all the packages. I want to see which Linux kernel not Linux kernel version, which ImageMagick installed, all that kind of stuff, like which versions, OpenSSL. Kernel version is different. You do kernel release, and secrets, basically this -l is basically just says, give me all of the attributes that every node has, and I'm just going to grep for maybe password. But you can just look through all of this and find maybe useful bits of information. You're not supposed to put secrets in this. It's not a best practice for Chef development. People do this all the time, where they put passwords, secrets in here. I've seen SSL keys, and all of this from the Chef server. You can find even more data. Where you're supposed to put things is this thing called databags. So, we use Chef. We store our pub key certs in our databags, and you would show them like this. You can run arbitrary SSH commands like with Salt or Ansible, but this isn't going to be super useful for you because you need SSH auth, and if you have SSH auth as an attacker, usually you have everything you need already and you don't need to use Chef. But this is just kind of for completeness. Sysadmins usually like using knife SSH. So if you want to backdoor Chef, it's pretty simple. The first thing you want to do is you want to find a recipe that's the most used because you want to backdoor everything, right? You want to get your stuff everywhere. So all this is going to do is just find the most common recipe that's used. So on my system, Zeesh was the first, which obviously makes sense because it's a shell and every machine wants a shell. We also have Sudo on our machines and Slack. So we're going to download the cookbook for Zeesh, and we're just going to add our backdoor to the Zeesh default recipe. I'll show you what that backdoor is in a minute. And then as soon as we do that, all we have to do is upload it. You don't have to do git commit or anything. If you have access to this, you can actually just talk to the Chef server directly, which is really nice. You don't have to bother leaving a trail of like commit messages or anything. And the backdoor that I wrote for this is just very, very simple. Run this bash, download this SSH script, and just execute it. And this is very simple. You could write a really nice one that was idempotent and all that kind of fun DevOpsy stuff, but this is just very simple. And then every single node that wants to install Zeesh is now going to run this every time it runs. One thing I want to talk about is microservices, because this is a kind of a defining feature of SaaS companies. They're really small services that do a few things. They're kind of like the Unix philosophy applied to services. So instead of making a huge program that does everything, you make a tool like Cut, which just cuts strings up or something like that. Usually they're centered around some kind of business area, like if you have a to-do part of your app, you have a to-do list service, right? Like in Gmail has a to-do little thing, and that's probably some microservice somewhere. They usually communicate exclusively via API. There's no shared memory or anything, nothing like that. Usually it's REST, which is over HTTPS and JSON, but sometimes you see some kind of queuing system like RabbitMQ, Amazon's SQS, that sort of thing. Why do we use them? Why do developers like them? It's faster development time. I don't have to consider this huge code base. I can consider a much smaller code base when I'm making my changes. It's easy to separate your code logically. My code to do to-dos has nothing to do with my code that sends emails. They're different, so I can keep them far apart. It's very easy to monitor, and services can remain partially up during disruptions. This is why you might see, like on Gmail, where calendar is not working, but certain aspects of like maybe Google Drive is working. It's very easy to test and release automatically. It's much easier to test and release. I'm just going to change this one small aspect of my code instead of my entire company's entire code base. So if we had a to-do list application, here's our user. It's going to download the front end, maybe Angular or React or something. It's going to hit the auth load balancer, talk to some kind of login auth service, which is going to talk to its database. And then once it's logged in, it has some login cookie or something like that, it's going to now talk to the actual microservice to do. It's going to talk to one or more to-do services, and it needs to talk to the auth service to make sure that it's logged in, because now the to-do service it doesn't know who's logged in, right? So it needs to talk to something else. It's going to talk to the auth service, hey, is this a valid cookie or something? Then it needs to talk to the to-do database, kind of a tongue twister, to make sure, like, to add new to-do items. It might talk to a queue for some reason, I don't know, to do batch processing. And the questions you might start asking yourself is like, how is this authenticated? How is like service to services authenticated? Is there rate limiting? Is there input validation? And one thing I like to do is like, is there SQL injection all the way in like kind of the back end? A lot of people do SQL injection kind of question response, but there's actually a lot of batch processing in a lot of these SaaS applications, very, very common. And SQL injections actually tend to crop up, everywhere. And a place that they're not very well tested is like after being in a queue or something. I really like to draw a line here just based on like being a developer. Stuff to the left is usually pretty good. We don't mess that up quite as much. Like, load balancers we're pretty familiar with. We know how to secure them and everything. But then if you have access to anything on the right-hand side, that's where we've messed up. That's where we've cut corners and everything. We have not, if you have access to our to-do box, we haven't really considered what that means as a defender. So how do you figure out what the API is? This is pretty straightforward. Everybody knows Burp Suite. You're going to have auth.example.com as a login. You might have something as verbose as the to-do list service .production.example.com. And this is very instructive because now you know that they embed the environment in their URLs. So it might have dev or staging or QA in their URLs, and you can just flip that out and try to enumerate their different environments. One thing that I like, Burp Suite does this automatically, but a lot of programmers actually might not know about it, is you can use the web application description language or the WSDL. This is what it looks like, and like I said, Burp or something like that will try to find this automatically, but sometimes when I point this out to developers, they don't know that they're actually advertising every single thing that their application can do at every path. So in this example, this is some XML. It's going to describe the getting a to-do item. At path / we have to do, and in brackets is the ID. That's going to be some kind of ID. It's a string. You can see param ID string, and then our method is going to be get, and we're going to return application JSON. This just tells you how to interact with it. But as an attacker, this is super useful information because you know exactly what you need to put in to do this. And if you try to like fuzz or something outside of this, it's going to be not as fruitful if you're doing it within the bounds of this, because like Jersey and that kind of stuff is pretty well tested, and the application code is usually a little less well tested. And usually this is just at /application.wdal for Java, but there's also WSDL, and there's tons of these different ones, and sometimes programmers don't know they're there. Let's talk about some weaknesses, like how is this authenticated. One thing is interactions between microservices tend to get pretty complicated, and this is a pretty good argument against microservices at some level, because if you have 10 different things that are all talking to each other, it can get pretty complicated both from a security perspective and from just a normal programming perspective, because now you have to be like, okay, what happens when service A talks to B and then B is down, so it's trying to do this and that. It's pretty complicated. Something that I see a lot of people get wrong is service-to-service auth. So that means, like, how does the, task service need to talk to the email service to link tasks to emails? The most common, unfortunately, is just network-level auth. If you can talk to the service, you're allowed in. This is super, super common. And if you get access to any of their network, you can talk to it as basically anything you want. Usually, any create, read, update, delete operations you can do. The next most common is shared key custom auth. So you might have everything over HTTPS, and you're going to add just some header like X company auth equal to some string. And you're like, oh, it's over HTTPS, I'm safe. No network attacker can get in, but because it's shared key, if you get access to one of them, you have access to all of them. And it's only really slightly marginally better. Next one I see is pass-through credentials. I actually like this one. It's pretty simple for people to do, and you don't need to do some kind of complicated thing. It's basically you just act on the behalf of the user. So you are like the task service, and you have the cookie, and you're going to be like, I'm going to pretend to be the user, and I'm going to talk to this back-end thing. You do have to worry about server-side redirections and that kind of stuff. You have to make sure the user can't specify who it's talking to. But I like that. Do you have a question? Huh? Course, yes. Cross-origin requests. This isn't a big deal when you're talking service to service because it's not a browser. But yeah, people do mess up course quite a bit. I see that a lot where they just allow everything in and they've basically broken their browser's built-in security. Let's talk about the cloud real quick. The cloud, what's the cloud? Everybody knows what the cloud is. We don't need to talk about what the cloud is. Access keys. So one of the best parts about AWS and Azure is it has extremely fine-grained permissions, but ops and dev teams sometimes just give themselves wide permissions. I'm the CTO of my company. I deserve to have access to everything. I'll just give myself whatever. And that's just sitting on my machine, and it gives access to everything I have. It's pretty common. For AWS, they usually live in .aws credentials if you're using the AWS CLI. But really, sometimes they're committed to source control and then reverted because people forget that git revert is not the same thing as removing the commit. It just applies an inverse commit. So I like to use a command like this, just search for AWS keys. This one actually, this is not the official regex to use for AWS keys. It's the one I use, though. They actually have you just do any uppercase letter or number, but 20 of them. I've never seen one that hasn't started with A, and I get a lot of false positives when I just do that, because, just 20 uppercase letters and numbers, it hits a lot of things like, MD5 hashes, that kind of stuff. One of the best parts about the cloud is logs. So here is AWS's CloudTrail. So we have a bunch of logs here, like Andrew at the bottom stopped an instance, and then Eric logged into the console, and then Andrew started an instance. Very, very useful to have these logs. And you got to put these in some kind of SIM, some monitoring, gray logs, something like that. But you can disrupt logging, obviously. The most brute force way to do this is just to delete the whole entire thing. This is like the most loud, angry thing you could do, just delete all of the CloudTrail configuration. Just stop. The next thing you can do is just tell it to stop. It'll keep all the configuration, but it won't continue logging anymore. This one is really clever. If you update the CloudTrail basically to say instead of acting globally, you act in this one region, this actually restricts tons of API calls from being logs because the APIs are global. For instance, like S3 is global. Everything interacting with it is global. So there's no region. So this stops any logging associated with that. But you get some logs. So if you have alert in your alerting system that's like, if I don't have any logs, send me an email, you will still get some logs. That's pretty clever. You can also just do things like removing the bucket, which is going to silently start failing logging, because S3 CloudTrail is going to start storing all the logs in the bucket, and if there's no bucket there, it can't store the logs. This one made me laugh. An S3 lifecycle rule to delete the logs after 1 second, which you're probably not fast enough to get the logs. And this one was pretty clever. Encrypt the logs with a key the company doesn't have. So the logs are in S3, they're there, but you can't read them because you didn't configure it encrypted, and they just changed your KMS key, and now it's something else. I got all these ideas from this blog post by Daniel Grizelak. Really clever, and there's tons more here. So the lesson here is if you're a defender, you have to look for every single one of these different ways your logging can be disrupted. Like not only just are you not getting any logs, but like partial degradation and that kind of stuff. AWS Remote Access Tool. It's like, how do you persist your compromise of AWS? If you've gotten access keys or something, how do you keep it? If AWS is an operating system, like Dino Zozovi was saying, if you just use a user with credentials, those users or credentials are often audited. If you have any company of any scale, one of the main things is that they'll say, okay, well, let's print out a list of all the users, and they're going to be like, who's this person? That happens in basically every company, even pretty minor companies do that. If you start an EC2 instance and just use that costs them money. So what do? So I think lambdas are the best tool here. And if you don't know what a lambda is, it's serverless computing, which some people kind of get miffed by because it's like, well, there is a server there. It's just you're not running it. So you upload code. You don't run Linux anymore. You just upload code. Here's my code. Run the code when this API is hit. It's kind of, at the moment, it's underutilized. Some kind of people are trying to build entire businesses around it, but it's not super common yet. The most important thing is it's free tier eligible. So it does not, if you use a very small amount of it, it does not cost the company money. It will not show up on their billing reports. So when the CFO is looking at it, he doesn't see, what is this Lambda thing, and then sends the developer off to go look at it. You can assign a role to the Lambda, and roles are nice because they don't have access keys. You just say, this Lambda can do this. It can upload things to the S3 bucket or something like that. And roles are less often audited than users, right? Because roles are a means to an end, and you're never going to log in with a role. It's about machines. And the last thing we're going to do is we're going to deploy in a region that they don't use. AWS has like 20 regions, and if you've ever used AWS, the way to look through different regions is to go into the upright, click the regions thing, and then manually switch your region. To look for instance, if you wanted to look for this remote access tool in your account via the UI, you would have to first go in your region, click, and then go to the next one and click, and go to the next one and click, and you'd have to do that 20 times. Via the API, you can do that pretty quickly, but if you don't know to do that, you wouldn't be doing it. Demo code coming soon. Nearly done with it. You can issue commands remotely, which is cool. It messes with logs via the update CloudTrail one, where it disables global logging just during its own operation, and because it disables multi-region stuff and it's deployed in a region that you are not in, it tends not to have any logs associated with it. And some advice for using it is basically don't cost the company money. The thing that companies pay attention to the most is their spending, and usually the CFO is asking a lot of questions. Exactly why did our S3 usage go up? That kind of stuff. And you got to research which events are generated. This is still kind of a new field. Advice for Blue Team. You got to restrict direct developer access, which engineers tend to bristle at a little bit. But you can sell it to them by telling them, actually, we're going to automate everything. Instead of you logging in and typing on servers, which is a bad idea, we're going to automate everything. And developers tend to get behind that. And even if you're taking access away from them, they tend to like it because they like automation. Continuous integration, despite the kind of cool thing we did earlier, is actually a great boon to security because you're constantly testing your software, and you can include in your steps like a Nessus scan or code linting, that kind of stuff. Peer review is really, really great. Peer reviewing 100% of your code is something I highly recommend. Choosing your new tech carefully. A lot of people get tripped up by new tools, these new DevOps tools. There was actually some people were talking on Slack about this kind of nice key secret sharing program called Vault. But the way Vault works is when you add your secrets to it, you have to specify them on the command line. So you have to say, add this to Vault, add my secret password on the command line. And, well, if you're adding it on the command line, it goes in your bash history. And if you have access to your machine, now you have access to all of that, even though you don't have the secret Vault password. So actually, your bash history contains a complete plain text dump of everything in the Vault. And they specifically say, we're not going to fix that. That is outside the scope of our project. Fix bash, which is crazy. As a security person in the company, you have to be like, okay, well, how are my developers using Vault or all of these tools? And it's daunting. And then obviously you have to ask yourself, what happens if this is compromised? So like linchpin servers, what happens if my continuous integration server is compromised? How do we do that? How do we protect against that? Your Chef server, your Artifact server, your Bastion host. And these are very, very challenging. If somebody gets access to your Chef server, I don't have a lot of super great advice. But that planning that out is better than nothing. So yeah, how do you detect that? That's a key thing there. Cloud specific, don't use the root account. Use roles, not access keys. Access keys you basically don't have to use anymore unless you're using the command line tools. Recommend moving away from that. Roles are great. So if you are deploying anything into AWS or Google Compute has the same thing, Azure has a very similar thing. You can just give that EC2 instance a role, which lets it do things, because then access keys can't be stolen. Obviously, use 2FA always. Watch an alert on your logs. Including all of the disrupting ones, and segment your network using groups. This is something that ops people tend to, want to do. They want to make a software-defined network that is cool. The database is only allowed to talk to this node, something like that. And you got to audit your IAM regularly. Make sure that there's no backdoored user in there. What to alert on? Obviously, new access keys, just like any system. New provision users, roles, and groups, which is pretty uncommon. New instances, we alert on this, but it's super noisy. I don't know exactly what to do to make this less noisy. We start up at least 10 a day, and we shut other ones down. I don't really have any great ideas for this because attackers would do this, but we do this too. So if anybody has any really good ideas for that, I've been thinking about trying to model what types we use, what availability zones, but obviously stuff like suspicious console logins and disruption of logging, all the different ones we talked about. And there's tons more here, and there's really not a great list of best practices yet for what to alert on, from Google Compute or Azure, AWS, and I'd love if anybody has any resources about that. That's it. Any questions? Yes. It's very similar. basically Google Compute and Azure and AWS, for the stuff I was talking about, are basically comparable. They all have the idea of roles and access keys, and obviously you want to protect your access keys, not use them. Use roles. All of them support 2FA and that kind of stuff. All of them have a similar type logging thing, although I'm most familiar with AWS, which is why I talked about it here. Yep. Yeah. To lock down AWS? Yeah. So the question was, are there any open source tools or anything to lock down or secure AWS? There's a few for-profit companies that do that, which, and they cost a lot of money. There are a few. AWS has something called Trusted Advisor built in. It's not great, and they actually charge you a bit of money for it. And it basically says, oh, you don't have 2FA set up, which is mildly useful. There are a few, I'm blanking on the name of one of them, but the problem is that, and why there's for-profit companies that do this rather than open source, is it's a ton of work to figure out all of the different possible use cases for AWS and to recommend secure configurations. And there was one project, but I'm blanking on the name of that exact project right now. But it's very nascent. It's very early in this whole thing. So I don't know. If anybody happens to know, great.
One of the products in the Center for Internet Security
Yes. So, yeah, Cloud Checker. And what was that one? Dome 9. Yeah, there's a few for-profit companies like Evident.io, and there's a ton of them out there that do this. Yep. Cool. Any other questions? All right. Thanks, everybody.